Wait, no, that's
Yeah, we started M.
Equals
You can copy
C.
With single arrow?
Double.
Okay, and then?
CH3COOH, which is aqueous plus OH.
And I will now do attendance as well. So many things
Therefore,
that I am doing
Yeah.
that are not even part of education.
What cake
Um,
apples?
let me-
How did you sell?
Survive.
Yeah, KB.
Luca, Felix is not here. Nicholas, yes. Taylor, yes. Eric, yes. An A.
Yeah, he's getting surgery.
An A is getting surgery?
No, Felix.
Oh, for his hand, yeah. Is an A here? Yes, he is. Eshwan, Luce, Sophia, Teddy, Dylan, Sabine, James. Everybody else is here. Well done.
Okay, Echelon. CH3COOH times OH minus.
Wait.
Beautiful. Beautiful. Well done.
Over CH3COOH minus.
Okay, you could have just said it's products of reactants. I'm not stupid.
No, that's what it's really is. Zach is not a smart guy, actually.
Oh, I'm retarded. Eric, KA is right.
Okay. Dylan, no negative self-talk.
Okay. And then on top.
Can we negative
If
self-talk?
Zach was
You good shot. Zach, don't talk. What the?
Sophia.
Trust him. What I need is
Stop for a second. If I can get it, Eshwan. Now that you've written that, I want you to write the generic Ka for any weak acid A, and I would like you to write the generic Kb for any generic base A minus. Write out the equations and then write the Ka and Kb for both. Go. Generic weak base. There's the working.
Or a little black box. No, I like it. Sure. Everyone gets a crack.
Where's your KB for the first one?
We already did that.
We're confused on what the key
How did you do the KA? How do you do KQ?
We just did that.
So KA is just the same thing with that? And KB is the same thing with that? So just put five to it.
Okay, HA is the weak
I don't know if we're going.
What is HA is weak acid?
We got, because it's got an H. So what would A minus be?
That's not either.
Base. Yeah, we can accept the proton.
I'll do on you.
Yeah.
It kind of looks like Dylan.
Oh, my lips aren't that long. I know what you know.
What? Dylan?
No, I said my lips aren't that plump. That's my
Don't know the context. Dylan, what is acetate?
It's acetate CH3COO negative.
You have your table of polyatomic ions, but there's certain ones you should just know. Acetate's one of them, because all of the weak acids that are really common, like vinegar, which is acetic acid, their conjugate base is also going to have a very similar name. So acetic acid, acetate, conjugate base. What do we do to write with that? James. Formula.
water.
Plus water goes to To what?
To 3Q
To 3Q?
CH3COOH.
Excellent. I thought there was a moment I was going, I have to remember everything that happens when someone has a stroke. Plus,
Oh, hydroxide.
Wait, no, you're not.
excellent. Volunteer, what would the KB then be? Hold it. Who's not really? Where'd Eshwan go? Oh, mushroom. Okay. Volunteer, hand. So I don't get 5 people calling out. No, I'm gonna go with NA.
Right?
NA. What's the KB?
It's good. It's good.
How do you products over reactants? How you do a KQ? This is a KB, so it's the same thing but for a base. So what is products over reactants?
CH3CO minus.
CH3. Is that a product
What?
or a reactant?
Product. And reactant.
Reactant. And it's products over reactants. So which one first?
CH3COO. HTOOH.
I've not seen that.
Times
OH minus.
over
CH3CO minus.
times.
Nothing.
Excellent. Well done. You didn't fall for that trick. Why do we not put water in there?
That's liquid.
Liquid. Well done.
In liquid.
That's a liquid. Everything else is aqueous.
If there's 2 liquid, we include it, right?
If there was, but there will not be.
Why?
Because it's acid-based chemistry, it always occurs in water. It doesn't occur. We don't. If you were doing, if you have an acid in a ethanol alcohol solution, you've actually gone beyond just pure acid-based chemistry. You are now working on something far more complicated, and it would have a different type of Ka depending on if it dissolves in ethanol or not. So yeah, all the Kas and Kbs are completely different. We're not going to do that to you in grade 12. Yeah. Okay. So let's take all the people.
I'm trying my best.
What?
Oh, no.
You did good.
I don't know how to do art.
This is really accurate.
1 second.
Like,
This is A block
She has like, why do you
and tendons.
like hypnosis? Like,
Dylan just like kind of accurate if he was like.
my device that's in a car.
Where's the tendons? There we go. Over. And Felix.
That's just straight Dylan.
When you get rated,
It's Dylan.
Okay. Erase the board. Find your new person and find a spot on the board.
Oh my god.
Go. Go. Find your new people. New people. Did I put you people?
There we are.
You just got tripped.
How did I?
Why is it so good? This
I
is
swear sometimes it's no.
It does know.
Okay, everybody good?
It's so strong. Ankle Bailey.
Okay.
what's the stage?
Write the Ka for every one of the acids. Acid equation and the Ka. 1, 2, 3, 4, 5.
Wait, with what? Water?
It's an acid equation.
Oh.
Okay, we gotta write that reaction.
Okay.
Right, the acid
Are you ready?
Oh, they separate. Do they separate? Like Ka?
That's what we're doing.
Oh, okay, wait. So does it go
Oh, and then we were.
Oh, that's H. Oh yeah, it goes OH3.
Because you look at your thing on your sheet, it just highlights.
Wait.
Okay, next one. Do Mr. Duval, do we need to write the like actual like equation or is it just right there?
Does it go with
Are we
water?
writing
I want the actual chemical equation and then the Ka.
Is it reacting with water or is it just?
Yeah,
Well,
it just takes
at this point, I want to say acid equation, and then I want you to know what to do.
No.
I feel like he's implying water.
Yeah, wait, I'm gonna get a marker and I'm gonna do the other ones too. We can do it on
The
the
practical
same.
explanation is, especially for acid, you don't have to include water because it can just go H plus. So if you're in the habit of it, that's good, because for your bases, you need water to make the hydroxide. So, it's a good
Yeah,
idea.
that makes sense. Whatever has
Dylan, who is that?
That's me.
And then it says write the K.
Sophia did it. I can't draw it.
What?
Anytime I draw
Is it
stop.
good?
It's
Yeah,
accurate.
it's pretty good.
Like, does it actually look like him a little bit?
Well, from here without my glasses, it looks great.
That's awesome. Okay.
I should give you a red pen.
What if you read the K?
Oh, yeah, really.
That's right there.
Fine.
That's really good. I took a picture of it.
No. I don't know, I'm natural.
Now there's 5 of the
What else
equations,
would do that?
and yet some people don't have pens in their hand.
Well, okay, I'll do a different one.
Right,
You're doing
Nicholas?
2, right?
There's 5 of the
I'll
equations.
do each of
So there's no reason why somebody shouldn't have a pen in their hand.
Yeah, like.
There's empty space right
No,
there.
no, but I'm supposed to work on it.
But or you could both work
Yeah,
over
I'll
there,
do
and
2.
spread out.
Oh, I.
No, you're good.
Or you could pull that desk back and then you could both.
The order is kind of weird.
It'll work.
Yeah, no, exactly.
These are all reaction.
Yeah.
Good.
Okay, so concentration of this. Concentration of this.
This is 11:45.
Well, Mr. Newton, that's my question. So,
Okay. Over.
Yeah,
just
just
like
like
Jim
Jim
did.
did.
is there like a?
Pardon?
You were late that one time though.
That's the KA, not KQ. Because KQ
Oh,
is
that's
like
true, that's
a,
true.
KA is like a cat.
H2SO3.
Specific type of K, that's the KQ called
No.
KA. And this one,
Okay.
you didn't write down the KB.
No.
Terrible.
Wait, do we need to do the
So
K?
this
Oh,
would
it's
be
in
plus always mine.
Yeah.
Now, alright, okay.
Can be equals.
Products are right.
It's number 4 now?
Right, as right on here. Now they're not the same.
Okay.
This is this
Reactions actually that just
the reactions are very different. One's making hydroxide, one's making H3O plus. That's about as different as you can get.
Oh, so Ka is a type of
Acid is a type of KQ, and KB is the KQ for a base.
Oh, I thought it's like Ka times Kb becomes like Keq.
No, no, no. Ka times KB will become KW. KW. Yes?
Can you go back, please? I can see the.
Yeah. But you have it in your notes too, right?
What my notes?
Yeah. Okay. There you go. Has everybody got at least number 1 done? Looks like. Okay. We'll check our work. It looks like I don't need all that. Oop.
No charge?
Oh my God! Don't look.
Jesus. Yeah, throw it back. Okay, wait. Throw it back. That's a good throw. Oh, wait, you actually felt that.
Oh.
You remember playing jackpot in elementary school?
Oh yeah.
Let's play jackpot now. Mystery ball.
500.
You have to say like dead or alive.
You don't have any you want to play with.
Only do that when it's like, yeah.
You just automatically win no matter what.
Yeah.
So you got 4. Yeah.
That's correct. That's correct. It's negative in a way, so it's like.
Now, H2SO3, I want to check. Where's your number 4?
Is H2SO3 like a strong
Yes.
acid?
Pardon?
Is H2SO3 strong acid?
Is it? Oh, I'm not going to tell you.
Why can't you?
Because there's a way for you to look that up. And that's part of the knowledge you have to have. There you go. There you go. Don't use one-way arrows for things that aren't one-way. For number 4, you have H2SO4.
Yeah, exactly.
H2SO4 is vastly different from H2SO3. So just that. Your number 4? I'm going to check on that one.
Okay.
That's it. Everybody's here. Well done. Keep going. You don't even need to review it.
Yeah, he was only known for being.
Isn't he done?
I'm actually dead.
No. Let him be back.
Oh, I do actually.
What's up? There you Do you want to listen to a good house song?
Yeah.
Please put that away, Taylor.
He was just saying
Taylor,
for future, not now.
I was just
Lies.
No, how can you prove that?
There's no way we play songs in Chem class.
And the album cover is like a little like moped.
Please put that away, Taylor. Chemistry all the time in this book.
Chemistry is great.
Nope.
Yeah.
Okay. Now, a couple of things. For some of these, I reacted them with water, and other ones I did not. What is the difference between those equations? Why would I do it for some of them and not others?
Yeah.
Simplified. I just didn't want to write water. So, any acid equation, you can always react water and get the true product, which is HCl plus, or you can simplify it and take the water out. It doesn't matter. The Ka turns out to be the same because water is a liquid. It cancels out. However, if you do this with the base reaction, it doesn't work because the base requires water to react with, so it can be a proton acceptor. But you can do it either way for the acid, and you can get out a Ka. One thing I really liked, nobody reacted both of the hydrogens, and we did it in the stepwise fraction. Only for a weak acid, they only come off one at a time. That being said, if you reacted it with a strong base, both of them would react because a strong base is a one-way arrow that would take out both of them. Okay, let's go. New partners. Where is it? New partners. New partners. Let's see what it comes up with. There we go. Find your new people.
Oh, yes.
New
Oh
people.
my god.
That showed me.
Go away.
Yo.
Find your new people. Erase the old work and find your new people. Go, 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 go. Erase your old work and find your new people.
Can you pass the
And once everybody's ready, I will reveal.
Sodium is cooking up.
Where's this?
Give me that freaking mop.
What are we doing, Mr. Nixon?
I'm waiting for everybody. Dylan is still hanging out.
Oh, give it a gavel.
Give me the mop.
Give it a gavel. Come on.
Sophia, go find Nicholas.
Can you please sauce us with the questions?
I'm waiting for everybody to get ready.
We're ready.
We are all waiting for Sophia.
Oh.
5, 4, 3, 2,
Not ready.
1, 0, -1, -2,
I'm ready.
-3. Okay, go. Write the base equation and the Kb for each base.
Can you erase this? Can you erase this?
No, Echelon, put the towel in.
Also, I wanna help, but
How's everybody doing on the first day? Did that become HO3?
Oh, no, that's fine.
Or that's supposed to be HI? Pardon?
H-I.
I think you're missing an I or part of an H.
There.
That's an H?
And the rest are equals.
Oh, I see. You have a bad, well, get a new one of those, maybe.
No, it's just.
Okay. And what you can't read. It's so much fun writing KAs and KGs. We love it.
This is so like monotonous.
No, it's fun.
No.
It's fun. Here. I'll make it more fun.
Wait, don't look over IO3. No. Is it a race, Sophia? Let's see. You'll win. That's smart.
Oh, there's an actual whole playlist. Music to do formulas to.
I love that someone did that.
Nice. You guys done? Everybody seems to have done well on the first one, so I might as well just start.
Okay, I did not like pay attention during Lord of the Rings. I just saw the hobbits like hiking a little bit. Like, they're cool. I want to be like Huckleberry. That's what I took away. Yeah. Being a hobbit would be actually really cool. And then they go on like the little silly wall. Oh my god, they're so whimsical. They're so jolly. It's so, I don't know. Yeah. A literal meaning. What? I'm sure so. What kind of
Why did you take up 45 minutes?
They're so full of whimsy and wonder. That's what they are.
What's full of whimsy and wonder?
The hobbits. I want to be like a hobbit. No,
No, that's illegal. No, you do the. I'm illegal. No, you do. I just bought a button. Why are you buttoning it? Yes.
Where are you looking?
5 is HSO3 minus.
Can you to Madagascar?
Yeah.
Oh, such a good movie.
No, you are not.
Oh, that's what those condoms are for.
Oh, they're too small. Oh, it's not.
Oh, use the pen. Use mine.
I need something good out of a tragedy, you know? Instead of just being a tragedy, we can generate electricity from the tragedy.
Okay. In my scan, it seemed like everybody did it correctly. Do you need more time to write it in your notes, or are you good? You've got examples. I'll give you just another minute. So for this one, you had to add in water to make the hydroxide. There's some amphiprotic ones in there, because if you notice, these are all the products from your previous ones, so they can go back and forth. And HSO3 minus has one for both directions. How do you know which one to do if you have HSO3 minus and water, and it can be both an acid or a base? How would you know which one it's going to be?
Which one's like stronger?
How do we know which one was stronger?
Look at this graph or the table.
The table. And where would you have to look at it? So why don't we do that while some people are writing down? Where's HSO3?
Higher up than H2O.
Whereabouts?
It's like,
You can give me the number on the side.
it's 1 times 10 to the negative 7.
1 times 10 to the negative 7. 1 times 1. Oh, there we go. There's HSO3. Now that is for one particular equation. Where is it again if it's going to ask as a base? Because that's not it acting as a base.
Oh, I thought like 1.5
5 times 10 to the negative 10.
1 times 10 to the negative 10? What? Negative 2. Okay. Oops. So here we have it in 2 places. Now that number over there, what kind of number is that?
Which number?
That number.
Quite
What is
big.
that?
That's the K.
That's the Ka. This is not a Kb table. You can calculate the Kb from the Ka. However, as a general rule, until we do that, we can see that as a HSO3 acting as an acid, not somewhere in the middle. Over here, we have it acting as a base. If this number is very, very large, then the equivalent Kb for that is going to be very, very small. So it's very similar to pH. If you have, say, a pH of 2, what is your pOH?
4.
What?
4? What?
You have 12.
12.
Oh,
Because they have to add in 14. Very similar.
yeah, that's what.
If this is times 10 to the minus 2, the Kb is going to be 10 to the minus 10. Because they both have to add up to 14.
So how do you know whether it acts like an
Oh, because Kw is equal to Ka times Kb.
But 10 and negative 2 don't make
Oh, sorry.
14.
Negative 2, maybe negative 12. Apparently, my brain decided that 12 and 14 were the same number. I'm going to blame the pollen.
What also?
Anyway, hold it. Taylor, you had your hand up.
How do you, like, in this case, how do you know that HSO3 is going to act like a base?
So here we can say, okay, when H2SO3 is acting as an acid, it's times 10 to the minus 2.
Yes.
As this is a base then, the Kb
But like, how do
it
we know- how
is
do we
going
know-
to equal somewhere around 10 to the minus 12.
But how do we know, like, what it's going to act like?
And then you just compare them. Which is bigger, 10 to the minus 12 or 10 to the minus...
Oh.
Well, hold it, where... That's not it. Where is it? There it is. Or 10 to the minus 7. Oh, it's probably going to act as an acid. Does that make sense? So you just compare the two values when you get to that point. And that's just if it's in water. If it's in anything else and the other thing is not amphiprotic, then it will just be whatever it needs it to be. If the other thing is only an acid, then it will be a base. If the other thing is only a base, then it will be an acid, because then it will just do whatever is necessary for the reaction. Okay, next page. Relate the magnitude of Ka or Kb to the strength. And I'm going to shut off the music now since we're no longer working on things.
No, turn off one of those.
And this is using our table. We did this in a previous one. This is noticing now not just how it's written strong, but the stronger an acid, the larger its Ka. How do you calculate a K value again? Products or reactants. And so if you have a lot of products, then you're a stronger acid. This isn't terribly enlightening. You have a stronger acid, and then we even write it on the side here to let you know, oh, these are stronger. Now, this is where I get to say oxymoronic things like, it's a strong weak acid. The only defined strong acids are above here. They have an infinite Ka because there is none of the reactants, so they go all the way over and you have a number over infinity, which doesn't make any sense. But as we go to here and you see very large numbers, this is 0.17, and then as we go down, we get weaker and weaker acids as we're going through. Same for the bases. We're going to be able to calculate the KBs from here. And we're going to find that the strong bases are all down here. And they're going to get more weak as they go up, and we'll find out the relative value as we do that. So we can look up the Ka on the table. But for bases, we can't quite do the same thing. So for bases, where was I? There. The greater the Kb, the stronger the base. Did the table have Kb written on it? There's no Kb. It did not have the Kb. But the Kb can be calculated. And it is with this formula. Kw is equal to the Ka times the Kb.
Does it matter if the base capital or not? 'Cause it usually
As long as it's subscripted, no.
Okay.
Yeah. As long as it's small and subscripted, you're good. And of course, for most things, because at 25 degrees Celsius is where we're going to do most of these. So unless we tell you differently, you can assume that. Now we have a couple of things. And I think I want you, we know. Now, I mean, technically, I shouldn't even have to define that. This is something you kind of know or could figure out. This is just mathematically true. We know, what's the other formula we have for Kw?
Like the OH minus times.
So concentration of H plus times the concentration of OH minus, right?
Yeah.
Okay. Previously I asked you to calculate the Ka and the Kb for the generic case for HA and A minus, right? What I would like you to do is take that equation and solve for H plus and OH minus. Rearrange it algebraically. People are staring. So what I'll do...
You mean
Wait,
like
wait.
KW divided by OH minus?
No, we're not going back and forth.
I want the Ka equation for the generic And just give me, okay, you don't have to go to the
Okay,
boards.
so H equals KW divided by OH, and then
Just, what is the KA then?
KW divided by
K is the H plus.
No, like in the equation, it is what over what?
products of reactions.
Right? So what are the products of an HA?
A
The
minus
A minus
and H3O.
and H3O plus over
HA.
HA. Right? So, given that equation, solve for HA. Sorry, not HA. Solve for concentration of H plus equals. If you rearrange that so that this is on one side, what would that equal? 1 over 1.
Okay, it would be
HA over A.
KA
Ka times
HA
over A minus.
Excellent. Perfect. Now, if I have, I love math. In like a couple of slides, we are going to do something that is going to freak out all the math teachers.
Okay.
Now, if I have A minus, what is the generic KB for that? What does that equal?
It'll be HA times OH over A minus.
Yeah. Hold it. Yeah. Yeah. Now, if I want to rearrange that, so I have the concentration of OH minus equals, what does that equal?
KB by A minus over HA.
Is that good so far? Good? Dylan, good? Why are you not following along? What were
I'm
you doing?
still trying to fill out these.
No, you did it. It's fine. It's over.
Okay.
There's tons in your
wait,
book,
do
for
you want, like,
example.
the tiniest bit? Oh wait, no, I think I got it. Wait, I got it. Never mind.
Got that?
Okay, yeah, that's good.
Now we know KW, we've already defined, is the concentration of H plus times the concentration of OH minus. I would like you to take the H plus and the OH minus and substitute what they're equal to. So put them in there and tell me what you get.
K times KB.
Well,
Yeah,
it'll just be KA times KB because everything else will cancel.
because everything else will cancel. So if I take the H plus there, where is it? KW equals, I've got KA times concentration of HA over concentration of A minus. And I've got, did that one in blue, so I might as well keep going. And then I've got times KB, concentration of A minus, over concentration of HA. We get to go, ha-ha.
Just go battle.
Boom, 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 boom. KW is equal to the KA times the KB.
How does that
It
figure
must
out?
be mathematically so.
Wait, how does that
Is
figure
that
out math
eight?
teachers?
Oh, this doesn't. In a couple slides, we're going to have the thing that freaks out math teachers. Math teachers would like it. It's a simple proof.
Yeah.
Very simple proof. So we didn't have to do an experiment to figure this out. This is straight math. If the first one's true, this one has to be true. So we know if this is true, then that must be true because that's just the way the formulas work. So you now know two formulas. You know this one, and you know that one, and you all, well, not two, you know a whole bunch from before as well. But now we know that one. So, using this newfound knowledge, we've gone to the board a lot. Would you like to just work where you are?
Yes.
Okay, calculate the KB of F minus and HSCO3 minus 1. Where is KB on the table?
But you could just get it from, like you could get Ka from the table and then.
Right, that's how you have to solve it. Yeah. How are you going to solve it?
That way?
Yeah, that's the only way.
Oh, okay.
I mean, other than experimentally, you can always measure it. I hope we get to the one that frightens the math teachers. I just love that section. It is almost as annoying to them as sig figs are. And a thing very much like it absolutely blew my mind in university.
Why did I get such a big number? I got like 3.5 times 10 to the 10, like positive 10.
Yeah, that's way too big. You dropped the negative sign somewhere.
But my calculator. All you do is
Poor carpenter that blames his tools for the crooked house. And other things my grandfather said. Like, never trust the internet.
That's 2.8 times the negative value.
Oh, I don't know. I'm waiting to see. One of them, there's two possible answers. Only one's right.
Then how do you know which one's right? There's two answers.
Well, both numbers are known. You do like 1.1
There's a negative sign there.
times 10 to the negative 14 divided by. Yeah, but it's times 10 to the negative
4.
14.
Yeah. Okay. But that's times 10 to the minus 4.
You do like one
Is that not
Oh, I thought you said it was too big. That seems
No.
Oh, that's
That's
not.
that is this one.
Oh, you should ask me if it's right.
But then no, but when I divide this,
I don't buy anything. I'm spending all my money on
You
you.
divided it twice. What?
so look, I'm just like,
Show me
so I just
again.
input the number. So
Yeah.
this number is 3.5 times 10 to the negative.
Yeah.
I just input it. So
I don't know.
Okay.
I've used
Divide it by
Eric,
Yeah.
1 second.
Yeah.
Wait, how many is 6?
Oh, that's the previous number. Right. Let me see what your times 10 to. What are you doing? Like, start from the beginning. How you doing? I want to see you press number.
That's like such a good way.
Okay, yeah, you only pressed that once. You didn't go times 10 to the. Yeah, no. What I mean is you didn't do a separate thing. You pressed that once.
You left it over there.
Bro, it's like
I have
Oh! Hold it.
Yeah, it's for the
KB.
exponential growth.
Should equal. Yeah. Oh, yeah, totally. You're doing it the wrong way around. That's a math. You're doing. The problem's not with your calculator.
I mean, like these things.
The problem's with how you're doing it.
Is
Oh, you got the math wrong, like the algebra wrong. So, what is KW?
Product of reactants.
No, what is it?
1 times 10 to the power 14.
What is the KB for F minus? KB for, sorry, what is the K, what is the KA we're going to use?
3.5 times 10 to the negative 4.
So for those who are looking along, we find hydrofluoric acid. Here's our base. So there's the Ka we're going to use. It's the Ka for its conjugate.
Can you keep up with this?
3.5. And then what number do we get? What number do we get?
I got 2.9 times 10 to the negative 11.
2.9 times 10 to the minus 11. Is that, anybody get something different?
Wait, how many sig figs are there? Are there 2?
There should be, no?
Do you get this? I mean, I get it. But like,
There should be. Because we've got, if we go to here, these are all the 2 sig figs. So 2 sig figs. Unless we give you something else. Okay, 2 kW equals Ka times Kb. So Kb equals, we set it up the same, 1.0 times 10 to the minus 14.
Why is it negative?
What number do we use? What is the Ka? What number do we use for HCO3 minus 1?
4.6 times 10 to the
4.6 times 10 to the what?
5.6.
5.6.
And negative 11. Wait.
5.6 times 10 to the minus 11. Are you sure? Is anybody else have something different?
That's
It's actually
No, no, no. I want something different if you have something different. What other number should we
You
use?
get the number from, so you look at the acid side.
No, no, I'm asking for a number. I'm not answering your question. What's the other choice?
I lost it.
4 times 10 to the negative
4.3
1.3
times.
times 10 to the minus 7? Sorry?
4.3.
4.3 times 10 to the minus 7?
Yeah.
Yeah.
Okay. So now I'll show it, because we had those two. So it's HCO3 minus. We can find HCO3 in a couple of places. So we've got HCO3,
If you want the acid, then we use the acid.
HCO3,
like almost at the
to
bottom.
minus 7, minus 7. There we go. So we have it here, and we have it here.
That's the one we're using.
Which one do we use?
The acid one.
The top one or the bottom one?
Bottom.
Nope.
Oh, you know, it's a bigger number. I was like, it's 5.
It's not because it's a bigger number, the top one. Why? What are we calculating?
KB.
KB. What does B stand for?
Base.
Base. Which one of those has it as a base?
The 4.5.
The 4.3. Here's the base. Remember, don't drop the base. It's a base. We're calculating, and that quote doesn't even make sense in that context. It's a base, you need it on the base side. Here, if you calculate it using this one, you're calculating the KB of that, the base. And up here, when we calculated for, what did we do, F minus?
Yeah,
F minus. Notice, when we did F minus, F minus is here. It's on the base side. So when you're calculating KB, you have to find it on the base side. So, yes for KB. No. Slap yourself. If you're studying, you make that mistake, literally. Slap yourself. There is research when they were training, was it knights, in various techniques. There's a few writings showing that they found, because they, like, should we be different techniques, they found if they slapped them into a cold pond, they seemed to learn faster. And I'm sure there's nothing wrong with their methods, and they did double-blind trials and everything in the medieval period. So that's just what I'm going with.
Could we do that?
If you slap yourself, you must learn faster.
No, could we do that with the juniors?
You can't do that with the juniors because it is illegal. You can do it to yourself, but you can't hurt others because that's wrong.
If
Yeah.
they sign a waiver saying no, no.
You cannot sign a waiver allowing yourself to be illegally assaulted. And since they're minors, you'd have to get their parents to sign the waiver. And even if their parents sign the waiver, once they turn 18, they can say, I never did agree to it. And now you're still on the hook. Because if you're underage, you're not competent, and your parents acted against your interests, the court can always still say, no, actually it didn't count.
What if we just, like, brainwash the kids into signing this?
Yes, that's how you do it. You brainwash the kids. That's literally what you do. The Stanford Prison Experiment is often used. Not the Stanford, the Milgrams. I'm going to go on a little aside. How many of you know what the Milgrams experiment was?
What's the Stanford experiment?
No, that was a different lesson.
Different.
Milgram, the shocks for learning. That's so cool. So, two people enter a room. So we got Nick and Eric, and you both draw from a hat, and you pick out, and it turns out Eric's the teacher, Nick's the learner. Eric is going to ask questions of Nick. Now, we show every time he gets a question wrong, we're going to electrocute him. And we show you it, and we actually test you on the lowest settings so you can tell that it hurts. And then you go on the other side of a wall, and then you, through a microphone, you ask him questions. And every time he answers one wrong, you press the button and hear him scream. And every time he answers wrong, you don't just press the button and hear him scream. That's the first action. The second action is to go up a voltage. So the shocks get progressively worse. Now, in the original experiment, what you don't know is that Nicholas is not part of the experiment. He's actually part of the experimenters. He has removed himself and is not getting shocked. They just either have an actor or a tape recorder playing the screens. And all they're seeing is that will you go up in voltage? And at some voltage, it will say lethal. And then keep going. And at some point, they'll even stop screaming. You're zapping them and you hear nothing. You're past the lethal limit. And then every time, you're there and you're like, there's a scientist possibly in the room with you. You're like, no, and you'll be like, I don't want to do this. Like, for the good of we really need this information. You're a part of a very important study. It's very important for this experiment that you continue. And then they just wait and watch and see. Will you continue administering damaging to lethal shocks?
Wouldn't that be kind of
Simply
good, like
because
testing
you've been
people
told
for like
it.
the military? Like if you just listen that well to like what they tell you to do, it'd be like
Well,
Well, that was like
that's like perfect. Like put them in
That was
perfect.
fun
Like,
work.
well, this is
no mercy.
this study was very important in terms. Most people report it as people are willing to obey local orders just because a person in a white lab coat told them to. And the study actually showed the opposite of that. Whenever I see it in a TikTok or popular media, they report it wrong. Because they did this numerous times in a variety of conditions. And they found if you had someone in a uniform that said, you must continue, that's an order, lowest rate of response. People are very reluctant to follow orders if they hear that someone's suffering. But if you said, this is a really important experiment, we need these results to help our research, country, community, whatever. And and you brought in the idea of helping the community, people had a really high response. People even responded when there wasn't a person telling them that. They just had a tape recorder and it says, like, if you have questions, play the tape recorder. And they press play and it would say, it's really important for the experiment that you should continue. And they go, okay. And then they would keep doing it. Like, it's not even a person anymore, it's just a recording time to do. As long as it mentions supporting the community, people will do really, really bad things. So it's actually, if you're in the house and you're a prefect, as you've probably noticed, if you give someone an order, they're very unlikely to do it. But if you tell them this is really important, you could probably get them to do anything.
So we should have.
If you say, you're supporting the house, and this is really important to support the house. Now, you can get them to do good or bad things. This knowledge is up to you what to do it for. But by the way, Milgram did that in order to show how evil Germans are.
What?
It was right after World War II, and the theory was that Germans were more evil than the average person. So he did a test. He did a test run in the U.S., thinking that he'd get a response rate, and then he'd go to Germany and do it again and see what the difference was. And psychologists at the time predicted that less than 0.5% would go above the lethal limit. And I can't remember the exact percentages, but it was fairly high. Went past the lethal limit right in the U.S. He never bothered going to Germany because he just learned that all of us will do terrible things. Not all of us. Many of us will do terrible things if we think we're helping. The road to hell is not just paved with good intentions, it is good intentions.
Wait, and then what's the Stanford experiment?
That was when they grabbed random people, not random people, you applied for a study and wrote in like, hey, we need some people for a study. And you're like, I'll do it, I got
You get
paid $1. And they came and kidnapped you. The police put you through a booking and then told you you're not part of the study. And you were randomly assigned as a guard or a prisoner. They wanted to study the purpose of roles in a relationship and power structures.
But it got so bad that they had to stop
It was so bad, in less than a week he had to stop it.
Yeah.
And he realized he became a part of it because his job was the warden. And while he was doing it, his girlfriend came to him and said, you are being so terrible. I don't even recognize who you are anymore. Like, you've just subsumed yourself into this. What are you doing? You realize that he had no controls over the guards or the prisoners. The guards very quickly became very violent and tortured the prisoners because they're trying to get them to obey. One part that really came out that was very interesting is what really helps that dynamic is not the worst guards, because they're in there, beating up the prisoners. All volunteers, by the way. But the nice guards also really help that process, because you have the mean guard, and then later the prisoners, upset and talking to the kind guard, they'd be like, yeah, I know, he shouldn't have done that. And that just helps keep the cycle going, because then they would just have a moment of relief, and then they'd keep doing it. Nothing would ever change. It's probably one of the, he got away with that so badly. He was very famous at the time as a psychologist. He didn't suffer any repercussions. He didn't give any counseling to anybody who was involved. He just sort of let him go. I was like, haha. The guy who did the Milgram's experiment got a ton of backlash for it. He had meetings between the experimenters and the learners. He did counseling with them all. He did a ton of stuff to try to mitigate what he did. And he still got way more backlash than the other guy. This is why we want to check and see how are prefects treating juniors. Because we now know with certainty, if you're not given guidelines and you're just frustrated, that most people will resort to force, and it will get very bad very quickly. So Guantanamo Bay was a classic for that when the pictures came out of how the guards were treating the prisoners. And the guy who did that experiment looked at it. He actually testified in defense of the soldiers, because he said, this is what anybody will do if given that role and no guidelines. The fault lies with the higher-ups. But of course, none of the higher-ups got charged, only the soldiers who were actually there. You have to be checking on your groups, otherwise you'll get things like that. Anyway, never let chemistry come in the way of your learning, so that's aside. Hold it, what time is it? 11:41. Curses.
American waterboarding people.
What if you just have like
It was bad fast.
juniors though?
Pardon?
What if you have really bad juniors? Or in this case, like really bad prisoners?
If you have really bad anything, it's just our perceptions of what works and our media of what works is totally different from whatever the research shows. Torture, all research shows, never works. It just doesn't. Because if you're in a position where you have to say something to get out of it, then you will literally say anything. It is the most unreliable source of information. There's that old RCMP How to Interrogate People book that's really excellent. They were quite criticized for having this, but they show how to approach different. Like if your suspect has just has high school, dropped out in grade 8, has a university degree, how to treat the subjects, and all of them are just how to become their friend, how to give them what they think they want, and then once they have that, they'll confess to anything.
That's what like detectives do. Like if you watch any of the